Hey, this is NASA. It's good to see all of you, and I have to say it's great to be back in front of the camera again. It's been such a long time. YouTube channel's been a bit down. It's good to be back. Hopefully a bit more videos will come up some more frequently. Today's video is on titration. I want you to have a look at this question kindly provided by ExamPro. It's a past exam paper. A student titrated 25 centimeters cubed of hydrochloric acid with 0.1 mole per decimeters cubed of barium hydroxide. And the student titrated the volume of barium hydroxide solution to be used in titration calculation as 23.5 centimeters cubed. That's that one. Explain why the student used a volume of 23.5 centimeters cubed of barium hydroxide solution in the titration calculation. You've got to ignore any anomalies. Generally, the first result is going to be an anomaly because you don't actually know where the end point is. You take the average of all the concordant results. Concordant results are results that are within 0.1 centimeters cubed of each other. You can see that is going to be, that can be all of these. So this is an average, like the average of these four. And that should be 23.5. So that's that value that we're going to use. Let's get on to this part of the question. 25 centimeters cubed of the hydrochloric acid reacted with 23.5 centimeters cubed of the 0.1 mole per decimeter cubed of barium hydroxide solution. It gives us the balanced equation. Calculate the concentration of the hydrochloric acid in moles per decimeters cubed. Okay, so what are the important things here? Well, certainly we've got our volume of hydrochloric acid and our volume and concentration of barium hydroxide. Well, what do we want? It says we want concentration. So I'm going to put that there because that's our unknown. Our volume of hydrochloric acid is 25 centimeters cubed, but if you remember from this wonderful equation here, we need to make sure our volume is in decimeters cubed. Okay, so that's what we're going to do. That means we divide by 1,000. Okay, so 25 divided by 1,000 is going to be 0.025. So now what about so with barium hydroxide, we've got 23.5 centimeters cubed. Again, we've got to turn that into decimeters cubed. So divide it by 1,000, that's 0.0235. Okay, and we are given the concentration of barium hydroxide solution. Remember from here that our concentration can be written as moles per decimeters cubed, or sometimes moles dm to the minus 3. Okay. So I'm going to write this down here. So this is 0.100. Notice how it's in 3 significant figures. This tells us something about how we should present our answer at the end. Okay, so we've got 2 unknowns on this side and we have 1 unknown here, so we can actually use this to calculate number of moles if we stick it into this equation up here. So N equals CV, number of moles equals concentration times volume. So 0.1 multiplied by 0.0235 gives us 0.0 0.0235. Now we need to look at the ratio. We can see the ratio of hydrochloric acid to barium hydroxide is 2:1. Okay, so that means however many number of moles barium hydroxide has here, hydrochloric acid will have twice that. So I'm going to do 2 times 0.00235. And that should give us 0.00447. So you just have to use the ratios. If that had a 3 in front of it, we'd need to times it by 3. If that had a 2 and that had a 1, we need to divide it by 1. So we just need to look at the ratios and make sure that these match up. Okay, so now I only have one unknown here. I can actually complete my calculation. N equals CV. Concentration is equal to number of moles over volume. And so that is 0.0047 divided by 0.025 gives us an answer of 0.188. And our units are in moles per decimeters cubed. 0.188 units in moles per decimeter cubed. And you'll notice that that's 3 significant figures. Okay, and if we have a look at the answer, the mark scheme here, 0.188 moles per decimeter cubed. So very important, guys, just simply use this method. I'll catch you in the next one. See you later.
When you're kicking with me, it's about the little things, with the way you flip your